Hey guys, here's our next section comparing two means. So we're going to be doing the same thing that we've done before, this time with, of course, two means. So first thing we need to talk about is our shape. So we know that it'll be normal if it is stated normal. We talked about this before. We like that because it's short, quick, and easy. Second one is we have a sample size larger than 30. And then the third one is we have to graph our data. We'd have to graph both samples, okay? We're looking for outliers, and we're looking for skewedness. We're going to graph a histogram. We could do a box plot, or we could do a dot plot. Any one of those three will do it for us, okay? So we can do that and it'll be just fine. Then we have our center. The center, of course, is the mean. Of the sampling data. We have x bar 1 minus x bar 2 is the mean of 1 minus the mean of 2, or our second data. Okay. Then we have our spread, which is our standard deviation. So x bar 1 minus the standard deviation of x bar 2 is equal to x, the standard deviation, squared 1 and 1 plus squared deviation of the second and 2. And then we're going to take the square root of that, and that is our spread. And then, of course, we also need our 10% condition. All right. Let me pause it so I can write down the next part. So here's our example. Potato chips. Potato chip manufacturer buys potatoes from two different suppliers, Ryder Wood Farms and Camberley Incorporated. The weights from Ryder Wood Farms are approximately normal, with a mean of 175 grams and a standard deviation of 25 grams. I'm just going to come into here, underline that, underline that, underline that, underline that. Okay? The weights of potatoes from Camberley Incorporated are approximately normal, with a mean of 180 grams and a standard deviation of 30 grams. When shipments arrive at the factory, inspectors randomly select 20 potatoes from each shipment and weigh them. Let x of c minus x of r be the difference in the sample mean weight of potatoes from the two different suppliers. Here's our questions. A. We're just going to scoot this over so we can have it on there. A. What is the shape of the sampling distribution of x bar of c minus x bar of r? Find the mean of the sampling distribution, and then find the standard deviation of the sample distribution. All right, so A is going to be really easy. That's going to be, how do we know that, what shape it is? All right, shape is approximately normal because it was stated. I like that one. That one was easy. Okay. B says find the mean, all right? So the mean, remember, it's x of c minus x of r. The mean for C was 180 grams. That was the Camberley, and then Riderwood had 175. So the mean of the difference of those two is 5 grams. Pretty easy. All right, C. That's our standard deviation. That's our spread. So let's just do our 10% condition first. So 10%. 200 potatoes is less than 10% of each shipment. Okay, because we got to think we're having those big spud trucks coming through. All right. So then our formula was the standard deviation of x2, and since it's an addition one, I'm just going to go 30 squared divided by 20, because that's how many spuds we got. And the next one is 25 squared divided by 20. And if you want to pause it real quick, I'll give you that chance, then you could calculate it. But you should get a standard deviation of 8.73 grams. Don't forget your your squaring, okay? I'll admit to it, that's what I did, okay? Just spaced it, don't know why. Just like the good old days. Okay, all right, so then we're going to talk about our conditions to be met for a T test. I guess that should be a 2 sample. Okay, conditions met for a T test. So it's basically the same thing we've been doing for, it feels like forever, honestly. That's what we got to do our independent. We got to state our random. We need to state our 10% condition. And then we need to do our large numbers, or our large counts. And that's the same thing as A. We got to find the shape. So I'm going to put our shape there. I'm going to put normal. Okay, so we got to do those 4 things, just like we have been doing, like I said, forever. Okay? All right. So if the standard deviation is known, then our test statistic is going to be x bar 1 minus x bar 2 minus the mean of 1 minus the mean of 2, and then we're going to divide that by our standard deviation, which was standard deviation squared of 1 divided by n1 plus standard deviation of 2 squared over n2, all taking the square root. Okay, that's our test statistic. All right, that's if, again, the standard deviation is known, we can do a z-test. Okay, now if the standard deviation is unknown, then we need to do our standard error this time. So we're going to take the sample standard deviation, square it, and we're going to take the sample standard deviation of the second data, scoot that up, Nielsen, so we can see it. Then we're going to take and divide then we're going to take this, divide by n2, divide that by n1. So the 1's match up, the 2's match up, and that's my standard error. Okay? So then the T statistic would be x bar 1 minus x bar 2 minus the mean the mean of 1 minus the mean of 2 divided by the sample standard deviation squared of 1 divided by n1, basically our standard error. And we're going to take the square root of that. Okay? That's a 2. All right. So then, to do our degrees of freedom, we have two choices. Okay? We have a awesome, grabbing a paper real quick. We have this technology one. So S1 squared divided by N1 plus S2 squared N2. Then we got to square that whole thing. Then 1 over N1 minus 1 S1 squared N1 plus 1 over N2 minus 1 S of 2 squared divided by N2 is our degrees of freedom. Okay? Or we can go N1, so conservative, we'd go N1 minus 1, N2 minus 1, and that would be our degrees of freedom. Okay? We're going to cover more of this later on, but to try and get the videos a little bit more compacted, well, together, I put this together. So the homework for this video is on page 654. It's numbers 32, 34, 36. Don't do 52 yet. I don't know why I put that one up there. Okay? All right.